welcome to Ganit Academy. Multiply your success here. And today's topic is theorem on derivative of composite function. So the statement of the theorem is, if y is differentiable function of u and u is differentiable function of x, means composite function is y equals to f of g of x. Then derivative of this y is, we can write dy upon dx equals to dy upon du into du upon dx. So we have to prove this. We will start our proof. In this, if y is differentiable function of u, then by definition of differentiation, we can write dy upon dx equals to limit delta x tends to 0 delta y upon delta x. Again, u is differentiable y is differentiable function of u, means we can write dy upon du equals to limit delta u tends to 0 delta y upon delta u. Again, u is differentiable function of x, means we can write here du upon dx equals to limit delta x tends to 0 delta u upon delta x. Here delta x, delta u and delta y are not equal to 0, tends to 0. Okay, now we will start the, consider delta y upon delta x. Okay, now we will adjust delta y, multiply and divide by delta u. Delta x multiplied by delta u, divide by delta u. And now we will adjust, we will take cross, means delta y by delta u in a one pair, and in another pair delta u by delta x. Okay, so here we get delta y by delta x equals to delta y upon delta u upon delta x. Now apply limits. Delta x tends to 0. If we apply limit delta x tends to 0 delta y upon delta x equals to limit delta x tends to 0 delta y upon delta u, delta x tends to 0 delta u upon delta x. Now see, here delta x tends to 0. If delta x tends to 0, then delta u also tends to 0. Means we can write in place of delta x tends to 0 as delta u tends to 0. Means we can write here limit delta u tends to 0 delta y upon delta u multiplied by limit the second as it is delta u upon delta x. Now from this first, second and third, this three terms, from these three definitions we can replace this as, if we write this LHS as it is, and after that we will use this according to this limit delta x tends to 0 delta y by delta x, value of this is dy by dx, dy upon dx. Again, limit delta u tends to 0 delta y by delta u, value of this is dy upon du, and value of this limit is du upon dx. So in the final step we get here dy by dx equals to dy upon du into du upon dx. So how to prove this theorem? First, given that y is differentiable function of u is differentiable function of x, means y is differentiable function of x, then we want to prove this. as dy by dx equals to dy upon du into du upon dx. So first of all, consider the basic definition. If we consider that, then we will get dy upon dx equals to limit delta x tends to 0, delta y upon delta x, as y is differentiable function of x. Again, if y is differentiable function of u, then we can write dy upon du equals to limit delta u tends to 0, delta y upon delta u. Okay. In this way, first consider this step. This delta y upon delta x. And just here, multiply and divide by delta u. After that, make groups in cross multiplication. Delta y, delta u, delta x, like this. And write just like this. After that, take limit. Delta x tends to 0. Again, we have to change limit here only. Because as delta x tends to 0, we can take delta u tends to 0. So here we change delta u tends to 0. After that, apply these three definitions. We will get dy by dx equals to dy by du into du by dx. So this is the proof of the theorem of derivative of composite function.